good day, Algebra. We are covering the fifth of 5 rules for how to simplify an exponent expression. And this is the one, we've said kind of each rule has its own quirk to it. You know that you're multiplying by the same base when you've got the multiplication symbol. You know you're dividing by the same base when you've got that fraction. If you look at the examples here and everything down below in the practice section, what are you seeing they all contain? Sasha, parentheses, okay? So this rule is all about parentheses. And what we're doing here is we're taking a base and raising it to a power. And sometimes that base will be more than just a variable. Like that 4 there, you know, without parentheses, that 4 is not part of the base. It's a coefficient. But by adding parentheses around the 4n, now we're actually squaring 4n. It makes that coefficient part of what's being squared. That exponent is on the outside of parentheses. Okay? It'll also happen where you've got exponents inside of parentheses as well as a power outside. This right here is called taking a power to a power. We're squaring y, but then we're cubing it. Right? And we've got this fraction here in example number 3 as well. So we'll go over all of these in expanded form, kind of like we did with rules 10 and 11, and then write our rule for it and then just launch from there. But the mathematical property that we're using here is the distributive property. We talked about this last year. We talked about it this year in PO7. What does it mean to distribute something? And the context, you've seen this before, would be something like, 10 times 2x plus 1. You have to simplify that equation or solve for x. This is where you've seen it. Again, notice the parentheses here, right? So whenever you got parentheses, kind of be thinking that distributive property. But what does it mean to distribute something? Yeah. Oh, it's kind of. We're taking, in this context here, we're taking this coefficient 10 and we're multiplying it by everything in the parentheses, right? And then you can go and solve your equation from there. In this case, we're taking the exponent outside of our parentheses and we're distributing it to everything inside of the parentheses, every coefficient, every base, okay? How am I going to say this? Give the power to every base / coefficient in the parentheses. Okay? We want to take that power, whatever's on the outside, and give it to every base and coefficient inside of the parentheses. But first, we're going to take a look at it in expanded form. So 4n squared, the base of this power of 2 is the 4n. So in expanded form, it's going to be 4n times 4n, right? That parentheses, like I said, makes that 4 part of the base. It's part of what's being squared. So it's going to be 4n times 4n. And as you probably know, with multiplying, the order in which you multiply things doesn't make a difference. So even though these two 4s aren't next to each other, we can still combine them, right? We've got a 4 times a 4, which can be written as 4 squared. And we have an n times an n, which can be written as n squared, right? If you'll notice, when we say give the power to every base coefficient in the parentheses, if I distribute this 2 into my 4, that's where my 4 squared comes from, right? It takes on that power. If I distribute this 2 into the n, that's where my n squared comes from. It takes on the power. Very similar to what we do here. 10 times 2x, 10 times 1. We give everything inside of those parentheses the exponent on the outside. If you wanted to multiply this out and take 4 squared and write it as 16 n squared, either answer would be acceptable. But this one here kind of shows better this rule that we're talking about here. Okay? Questions so far? Do I have everyone with me? Okay. What's the base of our power of 3 here? What's being cubed? What's being cubed? Annika. Right, everything inside of our parentheses. So writing this out in expanded form, we're taking that 5xy squared and we're going to cube it. 5xy squared times another 5xy squared times another 5xy squared. Because it's in parentheses, everything is part of that exponent of 3. Okay? How many 5s do we have total, all being multiplied together? 3 of them, right? Even though they're not next to each other, that's okay. We can write that as 5 cubed. How many x's do we have, all being multiplied together? 3 of them again, right? X times x times x, x cubed. How many y's do we have, all being multiplied together? I'll give you a hint. The answer this time is not 3. Lauren? 6, right? We've got a y squared here. That's 2 of them. Then 2 more. Then 2 more. Total, it's y to the 6th. Okay? If we kind of look back at our distributive property rule here, take this 3, distribute into the 5. Well, that's where our 5 cubed came from, right? Distribute into the x. That's where our x cubed came from. But when we distribute to our y base, how do we get y to the 6th? John? 3 times, is it 2 times 3? Yeah. Those powers there, that 2 times 3, are multiplied. And we can see why that makes sense when we put it in expanded form, because we got a y squared, a y squared, a y squared. Total, that gives us 6. Okay? This one could also be written as 125, which is 5 cubed. X cubed y to the 6th, that would be okay. You can leave your coefficient just with the power as 5 cubed, or you can multiply it out to get 125. Questions on that? Got one more example to cover. This sounds a fraction. Yikes. What is the base? What's being squared for this exponent outside of our parentheses? What's being squared? Lila.
5n squared.
Keep going.
Oh, and 4t.
Yeah. Everything inside of those parentheses is getting squared. Okay? That's what the parentheses do. They make everything part of the base. So in expanded form, this is going to be 5n squared over 4t cubed times itself. 5n squared over 4t cubed. Okay? It's a good thing we know how to multiply fractions. 5n squared times 5n squared. What do we get? Multiply straight across. 5n squared times 5n squared. Okay. How many 5s do we have being multiplied together there? John? 2. So 5 squared. How many n's do we have being multiplied together? Anybody? 4, right? 2 here, 2 here. N squared times n squared is n to the 4th. If you look at just our numerator here, using this rule and distributing this power of 2, that's how we get our 5 squared. That coefficient there takes on the power. For our base of n, where we already have a power, like we did in the last one, we see that we can multiply them. 2 times 2 gives us 4. In expanded form, we can see where that comes from. We have an n squared times an n squared, that's a total of 4 n's. How about our denominator? 4t cubed times 4t cubed. John?
4 squared.
Good. Wouldn't be 9, it'd be 6. Okay? Because you got 3 t's times another 3 t's, that's a total of 6 t's. Okay? And again here, distributing this too, again, it says give the power to every base coefficient in the parentheses. We have to go to that 4 there also. And that's where our 4 squared comes from. We also have to go to our base of t, which already has a power. So like we saw in the last example and previously here, those exponents getting multiplied, it's kind of the shortcut, right? And expanded form, you can see why we end up with t to the 6th. If you wanted to write this as 5 squared written out as 25, n to the 4th, and then 4 squared as 16, t to the 6th, that's okay. Or you can leave it the way we have it there. Okay? So, our rule, our key points that can go on a help sheet. Notice how I've got 2 different types of bases here, a coefficient base versus a variable base. Okay? Both of them get the exponents, right? The coefficient bases, which would be, like this 4 here, this 5 here, our 5 and the 4 there, they take on the power and they can be multiplied out. Right? You could leave them as 5 squared or write it as 25. You could leave it as 4 squared or write it as 16. You could leave it as 5 cubed or write it as 125. The important thing is any coefficient that's part of that base inside of the parentheses gets the power when you distribute that in. A variable base also takes on the power. And as we've seen with virtually every other rule except for CO12, when we had a power of 0, it stays the same. Right? Our base of n, when it got the 2, you can't really multiply that out because you don't know what n is. So it's just n squared. It stays the same. Gets the power, stays the same. X became x cubed, gets the power, stays the same. Y remains a y, right? So the variable bases do get the power but stay the same. The coefficients, they can be multiplied out if you want to. That's the difference there, okay? What are you looking for? Ah, yes. There's some there also in my closet back there too. How about the exponents? What happens with our exponents when we distribute? If a base already has a power, we saw it a couple times here in these examples, what happened? When a base already has a power, what did we do? Lauren? Multiplied. The exponents are multiplied. Okay? So we have a rule in which the exponents are added. We have a rule in which the exponents are subtracted. And now we have a rule for which the exponents are multiplied. Okay? It's going to be very important that you put these on a help sheet and focus when we're going over them, okay, so that we're not distracting ourselves or others. Right? These rules can get very confusing when you start to combine them, which we're going to be doing in PO15. And so put these key points on a help sheet, okay, and do your best to focus during class so you can get the lesson. Right? Questions on any of this? Okay, let's practice. You're going to be annoyed with me more than you normally are with this first 6 because I do require you to write them out in expanded form first. Then, once you get that down on the second page, you can use the rule, much more efficient, the shortcuts, it does go a lot faster. But I really want you to get to see why this works, okay? Using the rule, for this first one here, 3n cubed, using the rule, can anyone tell me what this is going to simplify to be? We'll use the rule first and then prove it with expanded form. What's this 3n cubed going to simplify to be? Lauren? 3 cubed n cubed. Okay? And how she got there was by distributing this power of 3 into our coefficient. That coefficient base takes on the power. That's where the 3 cubed comes from there. And then the variable base, that n, gets it as well. Since n doesn't already have a power, we don't need to multiply. It just takes that 3 but doesn't change. When writing this out in expanded form, since we've got those parentheses there around the 3n, that's what's being cubed. 3n is the base here. And you can see in expanded form, how many 3's are all being multiplied together? 3 of them. So there's our 3 cubed. How many n's do we have being multiplied together? 3 of them. There's our n cubed, right? Obviously, the rule is much faster, which is why we want to know it. Okay, but expanded form can get you the answer also. Anybody have a guess at what the next one's going to be using the rule, not expanded form just yet? John? 2 to the 4th, okay. Okay, I like what you said about y to the 12th, but for that x there, when we distribute 2 times 4, would give us x to the 8th. Okay, that x does have a power of 2 on it, so 2 times 4 would be 8. But you're absolutely right otherwise. That coefficient of 2 is going to take on that power of 4, 2 to the 4th, and that y base already having a power of 3, we're going to multiply 3 times 4, 12. In expanded form, we've got 2x squared y cubed times 2x squared y cubed times 2x squared y cubed times 2x squared y cubed, right? Everything inside of those parentheses is what's being taken to the 4th power. So we're taking that whole thing and multiplying by itself 4 times. How many 2's do we have? 1, 2, 3, 4. There's our 2 to the 4th, right? How many x's do we have? Well, we've got 2 here, 2 here, 2 here, 2 here, 2, 4, 6, 8. Okay, x to the 8th. How many y's do we have? 3, 6, 9, 12, and that's where y to the 12th comes from there. Right? So that's why the rule works. Goes back to expanded form. The next one is what I really wanted to talk about here, that negative 4n cubed, and then that whole thing being squared. What's being squared, like we've said, everything inside of those parentheses. So we've got a negative 4n cubed times another negative 4n cubed. And the reason why I'm putting parentheses around this one where I didn't previously is because of that negative sign. Because when we distribute this power of 2, using the rule here, when we distribute that into our negative 4, that negative sign is part of the base, which means that we need that negative 4 in parentheses when we square it. Without parentheses, the negative sign is not part of the base. It needs to be in parentheses because it started in parentheses. There will be a question on your test regarding this, okay, as far as making sure that a negative sign that starts part of the base in parentheses remains in parentheses when you multiply it out. So negative 4 squared, we can see that we've got a total of 6 n's, so n to the 6th, and using the rule, 2 times 3 gives us the 6 there. If you wanted to write this out, negative 4 times itself is a positive 16, n to the 6th, that would be fine too. Okay? But there is a question on your test about a negative sign being in parentheses when it's part of the base. So star that, mark it, remember it. Okay, there you go. Yeah. The next page. Oh, there's some fun stuff coming up. Okay. Which one of the bottom 3 do you want to talk about together? I already know, but Connor? The middle. I was not expecting that one. Oh, okay. All right. The last one. What can we do here for this last one? That's just going to make our lives a little bit easier. Take a look at what we start with here. 3n to the negative 3rd over 2n squared, all of that being taken to the power of 2. So this entire thing inside of the parentheses is the base here. But how can we kind of make our lives a little bit easier before we distribute? take a look inside of our parentheses. How can we simplify this expression? That's going to make it easier to distribute when we get to that point. Anyone see it? Well, I look at that 3n to the negative third up there, and I see I've got a base of n in my denominator as well, right? And whenever I've got two like bases, I know I can combine them in some way, okay? And in this case, that n to the negative third being a negative power, where can I bring it? Anybody? Down, right? It's a negative power in our numerator. I can bring it to the denominator, and it's going to be made positive. So in my numerator, now I'm left with just that 3. And in my denominator, I've got my 2n squared. And now I've added an n to the positive third. So in total, how many n's do I have in the denominator of this fraction? 5. So before I distribute, I can write this to be 3 over 2n to the 5th. And so now, when I distribute in that power of 2, instead of having a negative power to deal with and multiple n bases, I really just have a 3 in my numerator. So that gives me 3 squared. That 3 just takes on the power. In my denominator, I've got my coefficient of 2, 2 squared. And my n to the 5th, which when I multiply 5 times 2, gives me n to the 10th. Okay? If you didn't move that negative power down first, you could distribute first. It'd just be more work to simplify it at the end, but you would come up with the same answer. So it's not necessary to do, but it does make the distributing a little bit easier. Okay? Okay. The other two on this page, or any from the next page that look intriguing enough to talk about together. Samara? No? Maggie?
Can we do the last page?
Sure.
The last one.
The last one on the last page. Okay. Let's see here. Ooh, my goodness. Okay. Well, very similar to the one that we just did here. Take a look at our parentheses first. Look inside. I see multiple bases of x. I see a negative power. And I see multiple bases of z. How can I simplify in my parentheses first? Let's not even touch the power on the outside yet. What can I do in my parentheses? Lauren? Sure. I can simplify my bases of x here by subtracting the powers, right? I've got 6 x's in my numerator, 3 in my denominator. That means I'm going to have 3 left in my numerator. What else can I do?
You would move y to the negative 4.
Yeah. I've got a negative exponent here, nothing else to combine it with, but I can move it down so my exponent becomes positive. Okay? What else? I've got 2 bases of z, which means I have to be able to combine them some way, somehow. Lila?
It would just be z to the second up top.
Well, not z to the second, because remember here that the z down here does have a power of 1.
Oh, so z to the
Just z to the first. Yeah, this single z in our denominator will cancel out with 1 z in our numerator, leaving us with 1 in the numerator. Okay? And this is much simpler to distribute that 5 into than what we had to start with. You know, we had 5 different bases to start with. Now we only have 3. We had a negative exponent to deal with. Now we don't. So when we distribute, our 5 goes into the x cubed. It gives us what? X to the 15th. Okay? It goes into our z. which gives us z to the 5th. And in our denominator, it goes to the y to the 4th, which gives us y to the 20th. Right? So look at what you have. If you're able to simplify any way, it's highly recommended that you do. Morgan. Sure, why not? Okay. Now, in this case, take a look inside of our parentheses. What could we do to simplify this and make this distribution just a little bit easier? What do you see in there? John?
You can take out the A.
Yeah. Cross out the a to the 0, right? We just said if you have a 0 power, just get rid of it. Okay? Now, I do see that negative exponent, but why in this case would it not be most efficient to move that to the denominator before we distribute? What about this particular question is going to make moving the negative power? Here it helped us, right? Here it's not really going to do it. Why? Lila?
It's not a fraction and the other power is also negative.
More so the second reason, right? We could make this fraction if we wanted to, but the exponent that we're distributing is negative, which means if we move the b to the negative 7th down to the denominator to make it positive, when we distribute it's just going to turn it negative again anyway. Okay? So it's best to distribute and then deal with any negative bases that we have left, or any negative powers that we have left, because we're multiplying by negative 2, every sign is going to change anyway. So that 5, it started with a power of positive 1. Now it's got a power of negative 2. It's going to have to be moved, whereas originally it didn't. This b to the negative 7th. Negative 7 times negative 2 is positive 14. Now we don't have to move it. C to the positive 10th becomes c to the negative 20th. Now we do have to move it, right? So when the exponent that you're distributing is negative, be careful at how far you simplify inside the parentheses. The a to the 0, that's a gimme. Always get rid of the 0 powers. But beyond that, think about what might be happening next. So now, circle our negative exponents. B to the 14th stays up top. 5 to the positive 2nd is now in our denominator. And c to the positive 20th is in the denominator as well. Okay? That went really fast. We're already out of time. My goodness. This is going to be due on Thursday, because tomorrow we're going to talk about the math packet. But finish CO14 and start to make your help sheet. Get all these rules written down so that you're well prepared. That, folks, is how you math.